Hi friends, today I am giving a lecture on solving non-linear or non-homogeneous recurrence relations. In the previous video, we are already solving one example problem on how to solve non-linear or non-homogeneous recurrence relation of second order. So please refer that video while you are solving or while you are watching this problem. Okay. Now in this video we have to solve another example problem on how to solve non-linear or non-homogeneous recurrence relation of first order. Okay. Now see this problem. This is the given problem. So solve the recurrence relation of a suffix n is equal to 3 into a suffix n minus 1 plus 2n with the initial condition a suffix 1 is equal to 3. So the given recurrence relation is this one. Okay, now I am sending 3 into a suffix n minus 1 on the right hand side is send it to the left hand side. Now it becomes a suffix n minus 3 into a suffix n minus 1 is equal to 2n. Okay, so this is c power n into a suffix n minus c power n minus 1 into a suffix n minus 1 is equal to f of n. Okay, in the place of f of n, so 2 into n is there. So hence we can say that f of n not equal to 0. That means 2 into n not equal to 0. Whenever f of n not equal to 0, hence we can say that this is a non-linear homogeneous recurrence relation. Okay. Next we have to find out which order. Okay. Here nth term is there and n minus 1 term, its previous term, only one previous term, that is n minus 1, n and n minus 1 is there. Hence we can say that it is a first order non-homogeneous recurrence relation. Okay, here this is f of n. Here f of n value is equal to 0. Hence we can say that it is a homogeneous recurrence relation. F of n not equal to 0. Here 2n is not equal to 0. Hence we can say that it is a non-linear homogeneous recurrence relation. Here only a suffix n minus 3 into a suffix n minus 1. N term and n minus 1 term are there. Hence we can say that it is a first order non-linear homogeneous recurrence relation of first order. Okay. So whenever the non-linear homogeneous recurrence relation is given, okay, the general solution is so a suffix n is equal to a suffix n power h plus a suffix n power p. Okay, so here this is a solution of homogeneous recurrence relation. This is the solution of particular solution. Okay, the sum of solution of homogeneous recurrence relation plus solution of particular solution, so is equal to the general solution of the given recurrence relation. Okay, first we have to find out this value. Okay, to obtain a suffix n power h, okay, substitute f of n is equal to 0 in equation 1. So this is equation 2. So in the place of f of n, 2n is there. So in the place of 2n, we are substituting 0 value. Okay. So then a suffix n minus 3 into a suffix n minus 1 is equal to 0. Okay. In the place of f of n, we are substituting value 0. In the place of f of n, 2n is there. Hence, substitute 2n value is equal to 0 in equation 1. Okay. Equation 3. Okay. We are already know that, or we know that the solution for first order linear recurrence relation is a suffix n is equal to c power n into a naught. Okay, so this is equation 4. This is the general solution of the first order linear recurrence relation. Okay, substitute n is equal to n plus 1 in equation 4. Okay, then we are getting a suffix n plus 1. In the place of n, we are substituting n plus 1. A suffix n plus 1 is equal to c power. In the place of n, we are substituting c power n plus 1 into a naught. Okay, so this is equation 5. Okay, so next one. Now I am taking equation 3. Here we are substituting n is equal to n plus 1 in equation 3. Substitute n is equal to n plus 1 in equation 3. Okay, so now we can go for this one. In the place of an, we suffix a suffix n plus 1 minus 3 into a suffix n plus 1 minus 1 is equal to 0. Okay, now a suffix n plus 1 minus 3 into a suffix n is equal to 0. Okay, now 3 into a suffix n can be sent to the right hand side. So a suffix n plus 1 is equal to 3 into a suffix n. So this is equation 6. Okay, now this a suffix n plus 1 value can be substituted in equation 5. Okay, so substitute equation 5 in equation 6. Okay, equation 5 is a suffix n plus 1 is equal to c power n plus 1 into a naught. Okay, substitute that value in equation 6. So that is c suffix n plus 1 into a naught is equal to 3 into a suffix n. Okay, now what is a suffix n value? Here a suffix n value is c power n into a naught. Okay, so from equation 4, so a suffix n value is substituted in equation 7. Okay, now c power n plus 1 into a naught is equal to 3 into, what is a suffix n value from the equation 4? C power n into a naught. Okay. Now c power n plus 1 can be written as c power n into c into a naught is equal to 3 into c power n into a naught. Okay, so here a naught value cancel, c power n cancel. Okay, so therefore c is equal to 3. Therefore c is equal to 3. Now c value can be substituted in equation 4. So c value is substituted in equation 4. Okay, so a suffix n is equal to c power n. What is c value? C power n into a naught. What is c value? C value is 3. 3 power n into a naught. Okay, so now we are getting, so a suffix n is equal to 3 power n into a naught. Okay, so this is a homogeneous recurrence relation solution. A suffix n power h is equal to 3 power n into a naught. Okay, now so this value is calculation is completed. Now we can go for this one. Oh, the given recurrence relation a suffix n minus 3 into a suffix n minus 1 is equal to 2n. Okay, the right hand side part contains 2n. Okay, so at that time we have to calculate the a suffix n power p. So whenever this part contains only constant, a suffix n power p is equal to a naught. Okay, this part contains in the form of 2 into n, or constant into n, then the a suffix n power p can be written as a naught plus a1 into n. Okay, this is the solution, particular solution of the above recurrence relation. The right hand side part of the recurrence relation contains 2n. Okay, if it is only 2, we have to write a naught. If it is 2n, the solution can be written as a naught plus a1 into n. Okay, so this is equation 8. Okay, then this is equation 9. Okay, so equation 9 can be substituted. Equation 9 can be substituted in equation 1. In equation 1. So this is equation 1. Okay, so in the place of a suffix n, we have to substitute a naught plus a1 into n. Here a suffix n is there, we have to substitute a naught plus a1 into n minus 3 into, whenever a suffix n is equal to a naught plus a1 into n, so a suffix n minus 1 value is a naught plus a1 into n minus 1. So that is a naught plus a1 into n minus 1. In the place of n, we are substituting n minus 1. Okay, is equal to 2n. Okay, there is no change in at all. Okay, only a suffix n value is substituted. This in the place of a suffix n, we are substituting this value. So a suffix n can be written as a naught plus a1 into n minus 3 into, in the place of a suffix n minus 1, we have to write a naught plus a1 into n minus 1 is equal to 2n. Okay, now so a naught plus a1 into n minus 3 into a naught, 3 into a naught minus 3 into a1 into n minus 1 is equal to 2n. Okay, next a naught plus a1n minus 3 into a naught minus 3a1n plus 3a1 is equal to 2n. Next, a naught minus 3a naught can be written as minus 2a naught plus a1n minus 3a1n plus 3a1 is equal to 2n. Okay, minus 2a naught a1n minus 3a1n, that is minus 2a1n plus 3a1 is equal to 2n. Okay, here minus 2a naught plus 3a1 is nothing but constant term and minus 2a1n is nothing but nth term. Okay, we have to equate the nth term. Here 2n is also a nth term. We have to equate the nth term only. So here this is nth term and this is nth term. We have to equate the nth term only. Minus 2a1n is equal to 2n. Okay, so n cancel, 2 cancel, minus a1 is equal to 1. So therefore a1 is equal to minus 1. Next, we have to equate the constant term on both sides. Here there is no constant term on the RHS side. LHS side constant term minus 2a naught plus 3a1 is equal to 0. Right hand side there is no constant term. Because of that reason we are substituting 0. But here nth term, we have to equate the nth term. Minus 2a1n is equal to 2n. So a1 is equal to minus 1. Okay, now constant term on the LHS side is minus 2a naught plus 3a1 is equal to, there is no constant term on the right hand side. So here this value is equal to 0. Now substitute a1 value in this one. So minus 2a naught plus 3 into, what is a1 value here? Minus 1. Okay, is equal to 0. Minus 2a naught minus 3 is equal to 0. Minus 2a naught is equal to 3. So a naught is equal to minus 3 by 2. Okay. Now once we are getting a1 value and a naught value, these are substituted in equation 9. So therefore a naught and a1 values are substituted in equation 9. Okay, so a suffix n power p is equal to, what is a naught value? A naught value is minus 3 by 2 plus a1 value is minus 1 into n. Okay, so a suffix n power p is equal to minus 3 by 2 minus n. Okay, so this is the particular solution. Okay, now this is equation 10. Equation 10 and equation 8. What is equation 8? This one. Okay, are substituted in equation 2. Are substituted in equation 2. Okay, what is equation? Here equation 2 is equal to okay. Now we are substituting equation 8 and equation 10 values in that equation 2. We are already know that this value and this value. Now we are substituting a suffix n. So this value is 3 power n into a naught plus, and this value is minus 3 by 2 minus n. So this is the homogeneous recurrence relation solution. This is the particular solution. Okay. Now here a suffix n is equal to 3 power n into a naught minus 3 by 2 minus n. So this is equation 11. Okay. So now in the given problem, a1 is equal to 3. This is the initial condition. So that is, if n is equal to 1, comma, then a1 is equal to 3. Okay. Substitute n is equal to 1 in the above equation 11. So substitute n is equal to 1 in equation 11. Okay. So in the place of n, we are substituting one value. So that is a1 is equal to 3 power 1 into a naught minus 3 by 2 minus 1. Okay. What is a1 value in the given problem? That is a 3. So 3 is equal to 3 power 1 is nothing but 3. 3 into a naught minus, here 3 by 2 minus 1 is nothing but 5 by 2. Okay. So now 3 is equal to 3 into a naught minus 5 by 2. It becomes, okay, 3 into a naught is equal to 3 plus 5 by 2. Okay. So 3 into a naught is equal to, so LCM 2, 6 plus 5 by 2. That is 3 into a naught is equal to 11 by 2. So a naught is equal to 11 by 2 into 1 by 3. So that is equal to 11 by 6. Okay. So therefore a naught value is equal to 11 by 6. So a naught value is substituted in equation 11. Then we are getting a suffix n is equal to 3 power n into a naught value is 11 by 6 minus 3 by 2 minus n. So this is the final solution of the given recurrence relation. Okay. So whether this solution is correct or not, by substituting n is equal to 1. So if n is equal to 1, that means a1 is equal to 3. If you are getting a1 is equal to 3, your answer is correct. So a1 is equal to 3 power 1 into 11 by 6. So 3 into 11 by 6 minus 3 by 2 minus 1. So 3 into 11 by 6 is nothing but 33 by 6. So 33 by 6 minus 3 by 2 minus n is nothing but 1. So 33 by 6 minus 5 by 2. Okay. So here LCM 2, 6. LCM is 6. So 33 minus 2 into 3, that is 15. That is 18 by 6. 18 by 6 is equal to 3. So we are getting a1 is equal to 3. So therefore our answer is correct. Okay, so this is the final solution of the given recurrence relation. Okay, in this way we have to solve the given problem. It is a lengthy problem. Please observe carefully. So thank you. Thank you for watching this video. If you like this video, please subscribe my channel name. So Dibbela Srinivasarao. Dibbela Srinivasarao. Okay, in the next video we have to solve another example problem, and this is the final solution. So in this solution, so here a1 is equal to 3, substitute n is equal to 1. If you are getting a1 value is equal to 3, your answer is correct.